Good morning. We don't have a lot of time, so I'm going to save the pleasantries and charge right into it. Let me say that whenever I do this talk on this particular project, I always want to begin with a couple of clarifications. I'm a philosopher after all. The first is to say that I think that if you're comparing science and religion these days, after 150 years of this, you need to have some new angle. And mine is that I'm not interested in sort of the classical philosophical problems of metaphysics or even the theological kinds of concerns that arise here. I am interested in epistemology, but that'll be rather sort of secondary. My focus is going to be on cognition, indeed on the cognitive foundations of science and religion. The second comment to make is I want to stress straight away as a kind of cautionary comment, and that is I don't pretend to have a comprehensive theory of anything. Okay, not of science, not of religion, not of scientific cognition, not of religious cognition. All I'm trying to propose are perhaps a few points of leverage that we might get in thinking about these matters. And that said, let me charge ahead. The talk will have three parts to it. Mostly I'm going to talk about cognition. Then I'll talk about what I'll in effect call the cognitive unnaturalness of science in a couple of slides, the cognitive naturalness of religion in a couple of slides, and then one summary slide if I have some time left. That said, let me move right to the first part. In both cognitive science and cognitive psychology, so-called dual processing views have been ascendant for really at least 40 years now. They contrast explicit reflective cognition concerned with conceptions and theories in sort of conscious reflection to implicit conceptions in what is mostly unconscious intuition. I think about, for example, the differences between sort of when you're carefully trying to sort of think about writing something, writing or perhaps arguing with someone about a topic, in contrast to the way that you ascertain, for example, someone's emotional state on the basis of, quite frankly, typically a pretty quick glimpse at them. There are a constellation of features that distinguish these. The reflective stuff is overwhelmingly conscious. It's rather general in its capacities, which is to say, we can think about a wide range of things. By contrast, the intuitive stuff that I'll be talking about is unconscious for the most part. It tends to be rather specific about particular domains, and I'll say more about that in a bit. Again, one is automatic, as opposed to the other being rather, again, conscious and deliberate. What is automatic is indeed also fast. Indeed, I'd argue that most of the time it's instantaneous. By contrast to, if you think about, whenever we carry out discursive activity, a fairly slow, more ponderous way in which we think to ourselves, and indeed quite often talk to ourselves. Consequently, the notion that one is very easily articulated, it is indeed, as it were, often talking to ourselves, in contrast to a set of skills that human beings have that for the most part are not verbal, and indeed when pressed, most folks find it a bit of a challenge to sort of articulate exactly how they know what they know. Now, that said, what I'm going to be interested in is this intuitive stuff, the cognitively natural stuff. Human beings presume that this is sound, even though from a philosopher's standpoint it is woefully underdetermined by the evidence. Again, think, for example, about how you read someone's emotional state by looking at their face or hearing their tone of voice or their bodily comportment. It involves both knowing how and knowing that. Knowing how to adjust your gait as you walk across an uneven terrain, but also knowing that, well, for example, if your home is like mine, when the telephone rings at about 6:30, you probably instantaneously draw the inference, someone is trying to sell me something. I use that second example because I want to draw another distinction. And that second example is an example of, in effect, the sort of second kind of practice or intuitive cognitive naturalness, and that's what I call practice naturalness. What I mean here are simply the kinds of skills and abilities and insights that human beings have on the basis of having a lot of experience or practice in some domain. In effect, what I'm really talking about is an expertise, forms of expertise, but I don't mean anything particularly esoteric or fancy about that. I take it that I've probably got an audience. This room is filled with people who are experts at using cell phones. I'm actually less expert at using cell phones, and so I'm deeply envious of your practice naturalness, that a lot of things just sort of come naturally. For the senior folks in the room, I mean, it's the difference between the way your administrative assistant can use a computer, which is faster than you, in contrast to the way your undergraduates can use a computer, which is 10 times faster than the way your administrative assistant can use your computer. Note, we have an idiom in English, and it's a perfectly normal idiom that's used all the time. We say that these things become second nature for people. They are sort of an oxymoronic acquired naturalness. By contrast, what I'm going to be interested in is indeed what I'll be calling maturationally natural intuition and cognition and conceptions. So let me press ahead and talk about that. What kinds of features do such maturationally natural capacities exhibit? Do they exhibit? I think that traditionally the sort of two big battles have been about whether or not the capacities I'm talking about deserve to be called innate or deserve to be called modules. I'm quite frankly not very interested in either of those battles. A little bit in the modularity one, but much, much less so in the squabbles about innateness. Their origins remain controversial to this day. In short, though, I will try to convince you that I think that you can characterize these capacities without having to involve yourself in those two concerns. So first of all, these are things that overwhelmingly appear early, though not exclusively, but most of them do. Most of them are up and running by what we count as school age, 5-, 6-, 7-year-old kids. And indeed, I'd suggest that's why school age is common, it seems, across all cultures. It may be just a function of childhood amnesia, but I'm not convinced of that. But it's also, these are systems that are up and running before human beings remember that they're up and running, which is to say, you remember when you learned to read, you remember when you learned to ride a bike, you don't remember when you learned to walk or to talk. They concern very, very basic problems having to do with human survival. I have in mind things like the perceptual recognition of faces, the cognitive discrimination of syntactic distinctions, and action responses in the face of environmental contaminants. They also define normal development. If you're a parent, and I suspect we've got a fair number in the room, if your offspring don't sort of exhibit these capacities on a fairly steady and regular and routine developmental basis, you're concerned. You take the kid to the doctor. There might be something wrong. I mean, this arose with my second granddaughter, who my daughter was very concerned was not crawling and you know, she was at 14 months and she wasn't crawling. So, you know, go to the doc. These capacities do not depend on any culturally distinctive support. They don't require instruction or schooling or cultural artifacts or preparations of environments in order to sort of facilitate the acquisition of these things. I mean, basically, for example, think about language. You talk around little kids, and they start talking. You don't sit there and instruct them in it. They just do it, okay? These systems constitute domain-specific systems at the end, if not at the beginning of their development. As I said, I'm not interested in squabbling about origins. In fact, one of the things that struck me about this is that if you look at developmental psychology, although there's huge amounts of interest and controversy about, you know, sort of what kids know when they're pre-verbal infants, the fact of the matter is, by the time kids are 6 or so, there's much less controversy about it, about what kids know. And finally, these systems engage when they're triggered by distinctive cues. A few diagnostic cues is sufficient to sort of kick these systems into gear. one way of putting this is that these systems are dumb. That is to say, they don't require a huge amount of, what, I have 5 left?
Yep. Sorry.
Okay, sorry. Yeah, it always goes faster. They're susceptible, and it leaves us susceptible to persisting illusions. Okay, I'm going to have to hustle. Examples. Language is the parade case. Research in developmental psychology in the basic physics of solid objects shows that 4-month-olds are able to understand that 2 objects cannot occupy the same space at the same time. Contamination avoidance, more generally, and hazard precaution. Paul Rosen has done work that shows that across cultures, there are principles that define this. When I was a kid growing up, it's called cooties. That is to say, we all know the rules, and yet no one taught us the rules. 1 touch is enough to contaminate. 1 touch is enough to contaminate you completely. The contaminant need not be visible, and so on. Okay, and last but not least, the last I'm going to offer is theory of mind, which I take to be involving at least 2 kinds of capacities. One that goes beyond our species, about simply detecting agents, potential prey, and predators in our environment. But human beings are really quite unmatched in dealing with a complex social universe by way of appreciating the fact that it's the contents of other people's mental representations that sort of help us figure out the world and what's going on in their role and actions. Okay, that's the end of the material on cognition, and I'm ready now to simply clarify my thesis. The cognitive processes and products underlying religion rely less on cultural input and reflective activity and more on these domain-specific maturationally natural cognitive systems than do those underlying science. Okay, what I'm going to do is now say a couple of things about science. One about the products of science, the cognitive products, and the cognitive processes. Likewise with religion. So at least 4 slides here. All right. The argument is, with regard to science's products, that the sciences reliably advance, usually sooner rather than later, representations that are radically counterintuitive. Science's products depart drastically from the deliverances of these maturationally natural systems about the way the world is. And indeed, what science is overwhelmingly about is figuring out how to sort of improve on those systems. In effect, science improves on our common sense. The world is very different from the way it appears. Right? I mean, our best physics says that is mostly empty space. Our best astronomical hypotheses tell us that right now we are moving at 1,000 miles an hour. Good psychology reveals to us things that at least people in some people in my field would think are conceptually impossible, like Anton syndrome. Anton syndrome is blindness denial. People who are blind who don't know that they're blind. It's a real phenomenon, okay? All right, that's my fast gloss on the cognitive products of science. Let's talk a bit about the cognitive processes of science. The cognitive science of science discloses profound challenges to grasping scientific claims and doing good science. Remember, I said those maturationally natural deliverances are automatic, and their operations lead to recurring intrusions into human thought, and these constitute obstacles to learning and doing science with both students and with experts. I can tell you about that research, haven't got time. Some of that research with regard to our abilities to carry out probabilistic inference was carried out by Amos Tversky and Daniel Kahneman. Basically what they showed us is that, again, both novices and experts, at least experts, when we sort of twist a problem in a way that makes it just slightly unfamiliar, turn out to not be very good at carrying out statistical inference. Also, inferential fallacies and failures, most specifically with conditional inference, that is to say, the kind of hypothetical reasoning that informs science all the time. A classic work in the history of cognitive psychology is the Wason four-card selection task. It basically tests these capacities, and of course, all the psychologists in the room know that humans are rotten at it, okay? And last but not least, more of a social consideration, what is known as confirmation bias. Again, not last of all, but the last I'm going to mention. Karl Popper, the great philosopher of science of the 20th century, said that science was about the testability of hypotheses. The aim was to falsify them. Ryan Tweeney and other colleagues have looked at this, and it turns out this is something that scientists find kind of hard to do. at least with regard to their own work. And most specifically what he found is that if you really sort of focus and concentrate on falsification in particular, that it in fact tends to impede people's progress in their research. I take it this is of a piece with what Dan Ariely calls the IKEA effect. People who build IKEA furniture at home tend to overestimate its value. It's theirs, they built it, okay? How does science proceed, let alone progress, in the face of such cognitive barriers? I'd like to suggest that it's because of a very special set of social arrangements that sustain the standards of science and most specifically demand replicability. Science, processes, before products, now let's turn to religion. Popular religions involve, and now on products, only modestly counterintuitive, in contrast to the radically counterintuitive representations, at most, of special agents that arise on the basis of normal variations in the operations of garden variety, domain-specific, maturationally natural cognitive equipment. This is stolen straight from Pascal Boyer, one of my colleagues. Boyer argues that religious representations are crucially constrained. They involve violations in only 3 ontological domains, namely intuitive physics, intuitive biology, and intuitive psychology, and they involve only 2 kinds of violations. Transfers, where an entire suite of properties from one domain is transferred to an object that's not in that domain. Examples would be a mountain that's alive, a snake that talks, and breaches. Breaches are simply a transgression of one particular assumption in a particular domain. So we've got a person who talks, who can cure other people instantly, who knows other people's thoughts. Crucially, Boyer argues that these kinds of minimally counterintuitive representations, in effect, approximate a cognitive optimum. That is to say, they're highly attention-grabbing in contrast to the esoteric and radically counterintuitive representations of science. Okay? They're highly memorable, and there is lots of interesting experimental evidence to support that claim. And they authorize default ontological inferences, and in effect, they are the things that make religion easy to acquire. That is to say, if you know that God's an agent, you don't need to know much else. You know that God has got preferences, he's got desires, he's got hopes, he does things, those things inform what he does, he's got values and norms, and we're off and running, as you can see. Okay, last slide on religion, that is to say, bearing on cognitive processes. I've argued that it's rooted in this maturationally natural cognition. I mentioned language. We're talkative creatures. Religious people are talkative. Scientists are talkative. People in universities are talkative. But how is it that religion engages language as a maturationally natural system? And I'd like to suggest that that pertains to glossolalia. These systems are automatic, remember. You can't hear the sound I'm making right now as sound. You hear it as language. You process it automatically. And that's the point. When people get these kinds of human utterances, what are the inferences? This is a human utterance. This must be language. If it's language, it must be meaningful. If it's meaningful, I better figure out what it means. This is the kind of things that grab human minds. I also mentioned contamination avoidance and hazard precaution. This is how religions mark off sacred spaces and sacred objects. That is to say, all you do is just cue these sorts of sensitivities in human beings by either walking a circuitous path around a space, or particularly monitoring something very carefully over and over, or perhaps a very, very particular kind of attentive set of motor routines. Theory of mind is unequivocally the most prominent of those maturationally natural capacities that religions engage. With regard to myths or narratives, they're stories. They turn on agent causality, yielding mnemonic advantages and instant plausibility, what Massimo Piatelli Palmerini calls the Othello effect. In short, if you have 20 events in a row and you weave them together with an agent producing those actions, humans find it really easy to remember. And that's not true if you just have 20 events that are, as it were, connected in some other rather less straightforward, intentional, agentive way. That's, of course, it depends whether or not you're on the autistic spectrum. Because, in fact, the interesting findings are that for people who are autists, that pattern is exactly the opposite. Okay? They are allegedly, by some people's characterizations, mind blind. Okay, likewise actions. As Christine said, Tom Lawson and I have written a couple books about that, but the argument quickly is just very simply that the same representational machinery that humans have for figuring out and representing actions in the world are the ones that involve how they also conceive of their transactions with the gods. And last but not least, the gods are mostly like us. Icons, of course, tend to look like humans, and most conspicuously, what they'll almost virtually always have are eyes, okay? But what I'm really interested in is even more deeply psychological anthropomorphism. That is to say, the gods are like us. God thinks the way we think, right? He draws the inferences we draw. He has the values we have. We understand how agents work. This has led to a body of experimental evidence on a phenomenon known as theological incorrectness, which is to say that across lots and lots of religious systems, this has been discovered now. That is to say that folks will, if you ask them what they believe, they'll engage their reflective, slow system and, in effect, recite doctrines for you. But when you put them in an online processing task, all of those doctrines go right out the window, and God basically becomes Superman. Last slide. Okay, this is the last slide. I'm just going to put it up quickly to give you the big picture. We've got two distinctions here, right? Here is my original one about reflection versus maturationally natural cognition. Up here is just a continuum. How much do you allow appeal to agent causality? Note, I'm not saying that there isn't reflection about religion. It's perfectly possible, and theology is but one illustration of it. But in short, that in fact, popular religion overwhelmingly relies on these things. One final last comment. I hope I've stayed under 20 minutes at least, and that is, note that from a cognitive standpoint on this analysis, the kind of classic project of comparing science and religion is sort of cognitively misbegotten, because both science and religion are more like theology and common sense explanations than they are like each other. Thank you.